Hello, in this video I want to introduce the polar coordinate. So the polar coordinate is a different way to graph things. It's a different coordinate plane. We are familiar with the rectangular coordinate plane, or maybe the Cartesian plane, and that deals with x and y. You would find any point on it by specifying an x and a y value, 3, 2, -4, -2. It's got an x and a y to describe every point on it. It's got straight perpendicular lines, so we call it the rectangular coordinate plane. But there are other types of coordinate planes, and one of them is the polar. In the polar, instead of using x, y to describe a point, you use r, theta. So r is a directed distance. It's kind of the fancy word for it. Directed distance from the origin to the point. And the origin right there is called the pole, actually. So you call that the pole. And then theta is the angle. And you measure it counterclockwise as we're used to for most angle measures. The angle can be measured in degrees or radians. Typically, it'll probably be radians because when you're using polar coordinates, you're using, more advanced math maybe. And if you understand radians, you understand that they're much more natural to math. But anyways, to introduce it, I put a polar coordinate plane that uses degrees. And so if I had the point 2, 30 degrees, how would I plot that? So notice how the polar plane has these circles that get wider and wider as they go out. Each of those is a specific distance apart. The first circle has a radius of 1, the second has a radius of 2, the third a radius of 3, so each circle going out has a radius 1 bigger. And so when I draw my r, that's saying it has a length of 2. So it's going out to this second circle. But where? Where exactly should I draw this? Because all of these have a length of 2. Anywhere on that circle, because we know a circle has the same radius length everywhere. Well, I need to draw the radius length of 2, the directed distance of 2, with a 30-degree angle measure above the 0 degrees. So that puts my point right here. I go out 1, 2, and then I'm 30 degrees above the axis. And then I draw an arrow because it's a directed distance. So if I want to draw that clearer, I go up, draw an arrow to my point. So typically when you plot a polar point, you're not just going to put a point, but the whole kind of vector pointing towards it. And we'll explain why that is as we go on. If I do 4, 90 degrees, that would look like I would go to 90 degrees and it's somewhere along here then. And how far out? 1, 2, 3, 4. There we go. That's that measure. I could do 3, -60 degrees. Well, you know how to do negative degrees. You just go clockwise. You go backwards with your measure. So I go to -60. So it's -30, -60. And I go out 3. 1, 2, 3. Here's the point. I could do 2.5, 210 degrees. So I go over to my 210 degrees and 2.5, 1, 2, and I have to estimate just like on a normal plane. If it doesn't fall in the line, you kind of estimate where it is. But what if I do this? What if I have the point -3, 150? What does the negative directed distance mean? So what that means is you're going to go to 150 degrees, but then that's the positive distance. That's +3. If I do -3, instead of going the positive distance, I go the negative, so I go the opposite way. So negative 3 comma 150 is actually this line right here. Let's look at that again to get a feel for it. So I'm going to erase all of these. Well, I'll keep the negative one we just did. If I do the point negative 2 comma 300, I'm going to go to the angle measure 300. I'm going to go backwards 1, 2. And there's my polar point. So let's try practicing plotting a few more points on the next plane. So we are going to plot these 3 points, and notice that now we're dealing with radians, okay, to get some practice with that. So 2 comma pi over 3. So pi over 3 up here at 60 degrees, and 2. So 1, 2. There we go. There's the point. And we draw our vector going out to it. 3 comma negative pi over 6. So negative pi over 6 means I'm going down a pi over 6. And I go 1, 2, 3. There we go. Just like that. What about negative 3, 5 pi over 6? So I'm going to go over to 5 pi over 6. But remember, it's a negative 3. So instead of going out 3, we're actually going to go back 3. Hey, so that lies right on top of the red one I just did. What does that tell you? An interesting thing about polar coordinates. These are the same. Okay, 3 comma negative pi over 6 and negative 3, 5 pi over 6 are actually describing the same point and same vector. That leads us to an important thing to remember. Polar coordinates are not unique. Rectangular coordinates are unique. If I say 3 comma 5, there's no other way to describe that point. But polar coordinates are not. And there's a few different ways that we can write the same point in a different way. Here we see one example, but one thing you already know is, let's say I have the point, we will draw the point 2 comma pi. So that would be this point right here. How else could I get that point? Well, it's pretty easy. I could just add 2 pi, 3 pi, 2 comma 5 pi. Because you know with radians, every time you add 2 pi, it just brings it around again. Or I could subtract 2 pi. So I have 2 comma negative pi, 2 comma negative 3 pi. Then I'm just going clockwise back around. So add or subtract 2 pi and I'll always get the same point. But there are some more subtle ways to do it, and you see it with the example we already did. I can make my radius, my r, my directed vector, negative. But then what do I do between the two values of the theta, of the angle measure? Let's do it with an easy value again of pi. If I want to plot the point 3 comma pi, here we go, 1, 2, 3, there it is. What happens if I just add 1 pi? So I do 3 comma 2 pi. That would give me this vector right there. Well, that's not the same. What needs to happen with that vector to get it back to be the same? It needs to be reflected or flipped. And I can do that by making the r value negative. So negative 3 comma 2 pi. So then I would go around to 2 pi to get that original dotted red, but then I'd flip it and go backwards negative 3, and there we go. It lies on top. So a way to get the same vector is to make your r negative, and then with your theta plus or minus 1 single pi. Or you can keep your r the same and add a plus or minus 2 pi to your theta. Either of those iterations will give you the same point again, a different representation of the same point. So let's try that out with our last example. So it says plot the point 2 comma 3 pi over 4 and then find 3 more polar representations that stay in the interval from negative 2 pi to 2 pi. So 3 pi over 4, that is going to be this line here, and I'm going out 2. So 1, 2. All right, there we go. So that's the point. We need to find 3 more representations of 2, 3 pi over 4. Now, they tell us to stick in the interval because without that, it'd be real easy. We'd just add 2 pi, add 2 pi, add 2 pi. So one thing I could do, I can go 2, and then I can go 3 pi over 4 minus 2 pi. That's the first one I'm going to try. And if I do that subtraction, I'm going to have to get common denominators. So this gives me negative 5 pi over 4. So this gives me the new point, 2, negative 5 pi over 4. Does that work? Negative 5 pi over 4. So let's try it out. 5, that'd be pi over 4, 3 pi over 4, 5 pi over 4. And then going out 3. So that does indeed give the same thing. Okay, can we try another one? Let's try that plus or minus 1 pi. So I change it to be a negative 2, and then onto the 3 pi over 4, let's add 1 pi. Okay, but to do that, again, I need common denominators. So plus 4 pi over 4, and that gives me negative 2, 3 plus 4 is 7 pi over 4. So we're going to do our angle, 7 pi over 4, coming around 5 pi over 4. There's 7 pi, but going negative 2, so we're going backwards. So negative 2 is going to line me up there again. That worked. Well, what if I try it again? This time I stick with the negative 2, but now I'll do 3 pi over 4 minus pi. What will that do for me? So we go 3 pi over 4 minus 4 pi over 4. And that gives me negative pi over 4. So this gives the point negative 2, negative pi over 4. Okay, try that out. Negative pi over 4 means I go backwards a pi over 4. And then we're going negative 2. So the other way, and it all lines up. So you see the 4 different representations we got to describe the same point. And all of them stayed in that interval negative 2 pi to 2 pi. So there's a kind of general introduction to the idea of polar coordinates. In the next video, we'll talk about how you can convert between rectangular and polar coordinates. And then also you can draw whole kinds of cool things by using polar coordinates. It opens up a whole easy way to graph pretty neat curvy graphs.